Hey everyone, Jonas from Island Works here again, taking a little detour from my usual project of building the fastest Porsche 964 that I could ever build in my garage. Today, we're doing this, which is the air intake of my 2.7 liter 1976 Targa. So someone told me in YouTube you should actually show the end result in the very first scene, then it's better for YouTube. So this is where we're gonna end up. This is how we got there. Today, we are going to recycle the old Porsche 964 intake that I had on that car before I made my crazy intake with all the stuff that I put into that one. We're going to recycle that and make it a bit better looking and modernize that car. So what are we looking at? Well, we're looking at the intake that used to be in this car that we're going to recycle because this car nowadays has something very different. It has this intake, which I'm covering in a different episode. So, take the lessons learned from this and figure out how we do something cool out of this guy. Here is the master plan. What do I need out of all of this intake? Well, I honestly would really like to keep this and tidy it up and make it look really cool. So we're going to save this. This thing in the middle, looking at how fantastically beautiful this guy is, I think this will serve a different purpose somewhere else to someone else, not me. So I'm going to put this to the side. So now that I've decided to recycle almost nothing out of the intake, I have these two that with some grinding, some paint and stuff will look beautiful. Somehow I need to control the air coming in, and I'm gonna follow the same concept as I did on the intake that I have on my big car, which is an electronic throttle body. Some of you will say, sacrilege, you can't put drive-by-wire on a 1976 Porsche. And I'm telling you, I can, because it's really good. And it's gives you so much control. So that's what I'm gonna do. It has carburetors now, and I can never get them to work the way that I want them to. So take some of the fun out of the car with an intake of this magnitude, with having an electronic throttle body. It will feel much nicer, the car, and that's why I'm doing this. I'm thinking that my old spare engine from my 964 will be a pretty good test jig for getting the intake built up. And as I have it together, then I can work on the things that are actually different between this and an old 911 engine, which is that car over there. Let's put the pieces here. With this little test jig assembled here, it looks just like a 964 intake should look on a 964 engine. This is a 65 millimeter drive-by-wire throttle. They exist in 76 as well, and 82. I usually use 82. This one is an 82 because that's 3.8 liters and a lot of power and all the good stuff and high rev and everything. For the engine that I'm building this one for, 82 will be too much. It will be difficult to get the idle running on that one. This is a 65. And it looks sort of right on this one. I'm going to design something in between here that will be for a 65 and a 76. And then I might try both, or I might try one, but I will have both at least. And I'm obviously joking a bit about giving this old intake so much crap. If you look at it, a lot of the stuff here has to do with it having a mechanical throttle and trying to manage idle and a good idle speed with an engine that is of the characteristic that a Porsche 964 engine has. They're quite difficult to get to idle properly, especially if you tune them. So a lot of the things here has to do with that. This, for example, this is an idle valve, and you have all of this stuff that has to do with these double throttle bodies there, and then you have the vacuum system that does a lot of things for the car, does a few things for emissions. Good to have, not very pretty to look at. Back in my studio, we're looking at what is going to be an intake at some point in time. The first thing I did was that I took the two plenums and I sent them to my good friends at Lost Boys Lab that helped me to 3D scan these, and that's of course a huge help if you can get the real geometry in there. And as you can see, I've already started. I've done up the intake runners, the feet, so those are just about done. The interface towards the intake runners is different on the old engines, the 3.2s and earlier. So I've done up a new design of those. Then for the interconnecting pieces of the plenum, I've designed up something that I think will work well. So we have the T-piece that kind of follows the flow, and then we have the resonance tube in the very bottom here. It's this piece here. So those are done up. I've started printing them out. I'm going to show you one of them. And over on the other side of my studio, we have this. So we are in full production here already. And over on this guy here, we're producing these. Right, so I've already fitted these up, so I know that these do fit. I'm just making 6 of them so that we can build an intake later. Over on this side, this one is just done with this funky organic support that you use there. Okay, so we're just gonna take this one off. Take this off. So, 76mm version, it looks like it's a really good fit. I have done for the 65 as well. That's the one I'm going to test assemble. This material is super nice for rapid printing. The color is fantastic as well. So this is an EPLA, it's called, from AdNorth. It's very rapid printing with it, and I love that. Let's give it a try. What we got? Got a little nice curvature to it there, helping the air come in. Got the manifold pressure sensor with temperature sensor integrated into it. Got 2 vacuum ports there, and beautifully done in 4 different colors because I ran out of material 3 times. Okay, well, let's see how this guy, and this is the 65mm throttle body, and there's a little O-ring in between there. Yeah. So here we go, here's the resonance tube. It's a lot simpler than the other one. But it has the recycled internals from the other intake. So the shaft, the actuator, even this little spring here. And then to get the thing to last, I integrate bearings into it. So you can see here there's a little bearing there. This was a little test piece that I had just to try out the mechanism. So I only printed yay much. Anyway, this is now workable. And yeah, it looks simple enough. Let's get this one in there as well. There we go. And the strange thing is that this is actually a working intake. So compare that with this guy, right? They do the same thing. Okay, so now we know that it fits, and that's great. Now we need to make sure that it also works. This side here is more or less done, right? There's nothing more to it than... Looking on this side, there is a little bit more work. And the work left here is this resonance flap, the one that changes with the RPM of the engine to sort of artificially change the length of the runners. This one needs vacuum and needs control. And the control of the vacuum is simple enough. It's one of these small little solenoids. I'm not reusing the one from the 964 because it's so gunky and big and large and in the way. So I was looking at reusing or taking the one that the 996 has and then finding a good spot for this one. And that can be, you know, I'm actually thinking over here it looks pretty good. The hose is very long, but I can cut that. So I could do something like this maybe, and make a nice little mount based on the little bracket there. That's a good one. And another thing that needs to come in here is the vacuum reservoir. And the vacuum reservoir needs to be connected with the vacuum ports. So this is just a little bladder in here, and it will ensure that you have vacuum even if the engine goes up and down in RPM. Then you will have vacuum so that you can control this resonance flap. If I fit this guy in here somewhere, then I will, or maybe I should mount it on the intake somewhere. Anyway, this guy needs to go somewhere. In the original 964, this sits on the airbox, but there is no airbox here. There's just going to be a filter here. So let's be creative and figure something out for this guy. So this is what I got for the first little piece there. It sits on a little sheet metal mount there. It's pretty sturdy, yet flexible. So that's always good. I used these. So this is a mount that I designed for my other intake, and I tried bending it in different ways. I'm gonna have to use a machine to get the bend really proper and maybe adjust it a bit, but it's essentially this, then folded around the clamp. I'm thinking I should do something similar on this guy. And for this one, I also trying to see if I can recycle the mount that I usually use. This is just a little sheet metal like this, and you stick it into this guy, and I've created two wings like that. This is very light, so this is stainless steel. Maybe it should sit just in here. So I could, just as a test, I could jam it in under this one. I'm not going to jam it in there in the end. I'm going to design something that fits perfectly, of course. But just to test it, I could try doing that. One thing that I need to consider is the hose routing. So this hose is supposed to go up there, right? So that's something I need to think about so that I get some sort of reasonable routing. So if I put it here and make up a nice design of the mount, of course, then the vacuum hose will need to go like this, right, to connect those two. That's fine. Then I will need to pull a hose up this way, down here, and then I need another one up here, right, to connect to the vacuum on the intake. Or I simply put a vacuum port on this one. That might be the reasonable thing. Let's connect these two first. Getting vacuum hoses to look nice is, I guess, an art in itself, and one that I don't master, but this is what I came up with. We have vacuum reservoir here. It's going to go under into the solenoid and then over to the actuator. Then we're going to cut this one just about there and add a little T-piece there, because we will need to pipe it up from here to the port up there. So it's difficult maybe to see, but there's a vacuum port up here that I installed. You could put that down there maybe, let's see. Then I put a or a check valve there, so that when there's vacuum in the intake, that will charge the vacuum reservoir so that the actuator can run. So if we put that one in there, and then we need something like this to go in there and go into that one. Wow, there we go, spider's nest. Playing around with the heat gun for a short while, we got this. So now it looks relatively slick. I changed the vacuum port up there. Gonna tidy that up in the design. But now there's a flexible arrangement there that sits pretty sturdy. And with that, I think it's time to tidy up all of this stuff. Wow, this is quite a lot of work, as you could see. It's not smooth all over. It's not, but it's okay, I guess. I've taken all the knuckles away. So my idea is that if I paint this with a paint that has a little bit of structure, then maybe I can get away with it. If I wanted to get this completely smooth, I would be in here probably an entire day. Try something that maybe will work, and that is to paint it with this Wrinkle Plus, which is a paint that kind of gives a little bit of structure that will probably hide the imperfections in this. If this doesn't work, I'm just going to hand it in to get blasted and then powder coat it. Let's give it a try. And wrinkle, wrinkle, here we go. 2 fine layers of the paint, and then a heat gun for this side. And it turned into something that looks a little bit dull, a little bit matte in the sense of the glare. Other than that, I think it looks pretty good. I think it looks better in real life than actually what it does in the camera here. On the other side, I made a complete blunder. Wow, look at this guy. Looks like it's got some kind of infestation or something. Wow, it's terrible. It was 2 thick layers of paint on that one, and then I used a heat gun from the outside, and that turned into something that I will have to blast and redo. We're down to finishing up the material selection for the centerpiece here. As we looked at previously, I started off with the process that I usually do. I take something that is very rapid to print in and gives you very few hassles printing. This is a material called EPLA. It comes from Ad North. I get most of my material from Ad North. It's great. This EPLA is very rapid and you don't really have any layer problems and need really minimal support to this one. It's also available in all the fantastic lucent colors as you see here, which makes it all the more fun. This takes heat deflection of 60 Celsius only, so you absolutely have no way of using this in an engine. And I tried some things, it doesn't work. Next step is to work a little bit more on the finish. This is the next iteration. This is a matte, this is a PET G Pro Matte, it's called, also from Ad North. It gives a very smooth surface. It almost looks molded. This material, though, the PET material, it takes up to say 80, maybe 90 Celsius, so too little for an engine. It's also quite brittle, so it doesn't work in this kind of rugged application where you need a little bit of ruggedness and ductile strength. Next iteration is something called Adura X. So Adura X, this is a nylon, a PA material. This material is incredibly strong. And this would have no issues whatsoever to work in the application. It takes temperature up to 145 Celsius, so this is really good. It is an FDM kind of process. So you have some challenges with support material and so on, so you get some places in the print that don't turn out perfect, but you know, it's cool and all. I might use this in my car, maybe I'll use this piece here because it's really good. What I have then used previously in production design is an industrial process. This is a process that provides a piece that is almost isotropic. And isotropic means that it has the same kind of strength or similar strength characteristics in different levels and different directions. And that's cool on a part like this. Surface finish of this is also PA, a modified PA material. It's got very nice kind of surface finish. It also is a little bit glossy, so oil will not really get stuck or get soaked in this because it's not so, I guess, hygroscopic in that sense. So this might be what I end up with in the end. If I make more of these, it's definitely going to be this material. I'm going to just pop these into the intake, give a final look, and then we put it into that car. So we get this one on there. We take this guy, something like that. Temperature and pressure meter. I've designed it in so that it tucks in just behind here. It's not an issue to get the connector on here. I did like this because I wanted to have really a clean appearance from the front of the intake, so nothing can be seen. All the junk is sort of behind it. So that was on purpose, and it was a little bit tricky getting the design to work with that, but I managed to figure it out. Then we have the seal for the thruster body, that's not correct, throttle body. In the downwards position, also so that it's not seen so much. And with that, we are going to just make some adjustments so we get the vacuum system to jive here. Get the hoses in there. Look at that! It's just about done. This is now, in all aspects, actually a working intake, apart from these being plastic, of course, but yeah. Really like how the finish turned out. There's a little smooth transition between this and this. I think when I go for the final manufacturing process for this, if I decide to change, then these will be aligned with each other. If I make any more of these, I will do it out of this process, right? And you can see the material transition between these two is really cool. So it will look very, very uniform. That's good. If you like these materials, I'm gonna post the link to Adnorth webpage just below here in the description, together with a little discount code if you find something that you like. Okay, time to move in to the new home. See how this is gonna go. Tight. It's a pretty good fit. First look at it. Yeah, it's new meets classic, or classic meets modern, one of them. I think it looks pretty good. Lots of space for the air filter, not an issue. And yeah, pretty good. It's very clean in there, as it usually is in these old 911s. So yeah, what do you think? And here we are, intake is in, everything is done. We went from this, with all these beautiful looking parts, to this. Why did I do this? Well, first of all, I had a Porsche 964 intake. The other reason is that this car has been bothering me and has been in my way all the time, taking my attention away from the Porsche 964, so I needed to get this out of the way. It had carburetors, which is great, fantastic, looking beautiful, but I could never get it to run very well. With drive-by-wire, it's going to be a completely different kind of feeling to it. It's so smooth. So I'm going to enjoy the car a little bit more because of that. This was a little bit of a pit stop, getting this car out of the way. Next time, I'm going to get back to the 964, putting the limited slip differential into that car, and I will see you then.